See the phase shift? I'm interested in that phase shift because I believe the coil, when it collapses, helps this give off a brighter light, which I believe that's happening. And in doing that, it creates a plasma tank circuit type of concept, because remember, this coil is in series with the input and output of that plasma. So the collapsing of that coil creates the inductive kickback high voltage, which excites the plasma. Just touching that, make it a bit faster. Off we go. Jeez, what happened? I completely lost it now. Okay, so the inductive kickback, when it collapses, excites the ions to create the plasma, and that would be pretty much a degree or so. See, I've got to get this a bit better. Okay, that's a bit less annoying for me, so I was having to look at that. That's pretty nice now. Almost silent, look. Just hear it hissing. There you go. So as that, sorry, I can't talk and have that drive me insane. Okay, I'm going to leave it that for a sec. Okay. So we're going to turn the light on. A little bit fried by it, actually. It's like pretty intense flickering. I'm going to disconnect my battery. Okay, now let's talk about this. I've got the big Wimmer on there. So 1000 volts, 1 microfarad DC, as far as I know. I have to look them up too. And it goes into this tube here. This tube here goes onto the one of the inputs. So you get input on this side, input on this side. The fact that you got these two here, this one and this one, make sure there's no charge in the system, that's irrelevant. That's actually only just for a starter in here. So that heats up and pulses with your starter capacitor and spark gap, and that gets your plasma going. Once the plasma's going, you can maintain. That's why they flicker on and off, on. So anyway, so what I'm saying is, when this collapses, it gives off quite a inductive kickback, which has got to go somewhere, and it can't go this way because there's a spark gap, so it has to go through the tube and through this tube. Now remember, this inductive kickback, it should be in the negative, but because we have an earth potential, let's say the earth is 0 and this inductive kickback's minus, I don't know, 30,000 volts, let's say it's coming out of there, maybe 20, cause it's only a small battery, maybe 10. The potential difference between earth and the inductive kickback here is 10,000 volts. Obviously very low current. Now to get the frequency up with a spark gap, I'm not sure how really to do that. I'm not sure of the frequency. I can check that at some point. I'll just put a probe sort of around here. And but anyway, what I wanted to talk about is phase shift and the degree. This clearly was out of phase quite a bit. probably even 50%, which is sort of strange because you think of the frequency here, and the flickering should be an indication, and it's really not that great a frequency, probably about, I don't know, 20 hertz, maybe 10 hertz. Is it flickering 10 times a second? Maybe not even that, I don't know. But what happens is you notice this is out of phase. I wouldn't say 180. I'd say probably, by my eyes, I'm thinking about 100 degrees out of phase. And this would contribute to that when it collapses. So you've got the current going through the wire, through the coil, and into here, and it's pulsed. But this collapses at the same also as a coil. I intend on doing it with Litz wire. I've enjoyed this experiment. I think this is one of my finer moments in playing around with this, because I've played around with a lot of setups and far bigger coils, far bigger fluoros, and far bigger power and multiple tasers and all sorts of stuff. And I've refined it down to this. And the idea of my testing is to be able to use very low power that we can create. We can create very low power, and if we can create low power and we can use that to create very high voltage, we then, I believe, potentially can create what we're creating here, and that is a energy difference in the potential to ground, to be able to charge and extract electrons into a capacitor. Now, I don't know if that's got charge in it. Probably does. I'm not going to touch it, that's for sure. It's probably... Oh, God, that scared the hell out of me, because I've actually done this a few times when it has been charged. And that just knocked on there, and I thought, oh, that's got no charge in it now. I hope that's got no charge in it, because I'm not going to touch it just in case, because I've had a few zaps. It's not fun. It's quite upsetting. Even little capacitors out of the fluoro starters, little capacitors in them have got a wallop. So there we are. I'm going to keep on playing around with this, and inevitably this will be one part of the system, and this will be another part of the system, and they'll be going to ground. So I'll have two grounds going out. So I'll have two parts of the system. And so basically the replication, instead of this wire going to just there, it'll go to a replication of that on this side. How's that for cool fun? All right, guys, I'm going to just play around, and if I see anything, I'll record it.